Whether you like it or not, anorans are relatively frail. If a predator gets a hold on them, it's most likely the end for them. That's why anorans typically employ preventive defense strategy. Some anorans are poisonous, some deadlier than others of course, but at least it makes them unpalatable for predators. Hopefully at least. Some have aposematic coloration, which further emphasize the fact that you should not touch them. Some employ specific display to deter predator, whether it's bluffing or simply playing dead. Meanwhile, some depends on detection avoidance. The most basic way is cryptic coloration, blending themselves with the surrounding. Passive camouflage, you could say. However, the frog that we're gonna talk about is a bit different. Yes, they do camouflage themselves to their surrounding, but they do so actively. Not by changing color like chameleons, but by, well, removing their color basically. Sure, there are several translucent animals, but a land vertebrate being translucent? Even transparent? Now that's definitely unusual. So, let me bring up the question. What exactly is glass frog? Glass frog is an actual frog. I did mention earlier that they are anurans, which means they are amphibians. Thankfully, glass frog as a group do have an actual taxonomic parallel, which is the Cantrolenidae family. Cantron means spike, while lede means elbow, so their name basically means those with spike elbow, named after their humeral spine, this protrusion right here. Though, in reality, not all of them have this trait. There are three traits that are widely considered to be their synapomorphies. To put it very simply, it's their exclusive character, diagnostic traits. Those three are the complete fusion of tibia and fibula, medial process on the third metacarpal plus intercalary element, and, last but definitely not least, is the ventral transparency, which I'll talk about in more detail later. Glass frogs are usually divided into two subfamilies, Cantrolenidae and Hyalinobatrachinae. They do have anatomical diagnostic traits. First of all, Cantrolenidae members have crista medialis in their humerus, while Hyalinobatrachinae members don't. And, second of all, Cantrolenidae members typically have long prepollex, around 50% of their first metacarpal or even more. Meanwhile, Hyalinobatrachinae typically have short prepollex. So yeah, so far it's quite clear. However, if we're gonna talk about the specific genera and species, it could be confusing. In general, two genera are classified in the Hyalinobatrachinae, which are Hyalinobatrachium themselves and Calciella. Cantrolenidae is more diverse, with 9 valid genera at least. However, some species are considered dubious and might be moved to other genera soon enough. Actually, maybe not soon enough, who knows when, but you get the point. Not only that though, one genus would be a special mention, and that is Ecology. Some authors place them in the Cantrolenidae subfamily, while others place them nowhere basically. By that I mean, it is placed as the sister taxon of Cantrolenidae and Hyalinobatrachinae. So, Ecology is technically in the family, but in neither subfamilies inside said family. Many things about them are quite extreme after all. For example, their prepollex is exceptionally long and big. And not only that, their crista medialis spans the entire humerus bone, and it's also big. So yeah, understandable why they are considered special. All in all, there are over 100 species of glass frogs. Might be more, might be less, depends on what happened to the dubious species. But even if those dubious species are considered invalid, it is still a relatively diverse group of frogs. Even so, their distribution is quite limited. They can only be found in Central America to South America, mostly in cloud forests, but also other types of forests there. Because their distribution is quite limited, not a lot of people know about them, even though there are over 100 species of them. But yeah, next, let's talk about their morphology. But before that, glass frogs are small, typically only around 3 to 4 centimeters long. Even some species that are called giant glass frogs are only around 7 centimeters long. I mean, to be fair, 7 cm is over twice the size of the smaller glass frogs, but still not a giant among frogs in general. All of them are basically green, or at least greenish. Some of them are quote-unquote plain, while others have white, yellowish, or even black spots on their body. Their dorsal side is opaque, or at least translucent, while their ventral side is transparent. That's why they are called glass frog. Different species have different degree of transparency. Some are partially transparent, while some are completely transparent. Their eyes face forwards, some with horizontal slit-like pupil, while some have wider pupil. Like most other frogs, they have 4 digits on their forelegs and 5 digits on their hind legs. The tip of their digits are enlarged. Males have nuptial pad, which is a thickened skin around their 4 digits caused by the presence of special mucus gland called nuptial gland on their forelimbs. Different species have different types of nuptial pad. In general, they have reduced webbings. Different species also have different webbing formula. Oh, and yes, you could formulate anuran webbings for taxonomic purposes. Oh, and I did mention this already, but the males of some species have humeral spines, while some don't. So yeah, these traits combined can be used to identify specific species. Naturally, their morphology correlates to their ecology, so let's talk about it. Glass frogs are arboreal, meaning they spend most of their time on trees. That's also why their distribution is limited to forests. Like I said earlier, they can mostly be found in cloud forests, which means moist and relatively stable, perfect for small amphibians like them. They are carnivores and they will eat small creatures, mainly small insects and other arthropods. Their green coloration blends them with the leaves where they mostly reside. However, like I said earlier, that's not the extent of their camouflage. While yes, having a transparent skin is unique and quite neat, that is not exactly enough for camouflage. Why? Because even if your skin is transparent, your internal organs are not. Not only that though, you have blood, which in most vertebrates would be red, and it will be circulated throughout your body basically all the time, as long as you are alive. So yeah, having only a transparent skin wouldn't help you camouflage yourselves. It would just make you look weird, or perhaps even creepy, even more conspicuous. So, how do they do it? Well, first of all, their organs are typically covered in whitish or pale membrane. Some species even have transparent organs, so it's not that conspicuous when a light shines through them. Second of all, when sleeping, they could pack their red blood cells inside their liver, hence drastically reducing the density of red blood cells circulating in their blood vessels. Blood is only red when there are oxygen-binding red blood cells in the blood. By drastically reducing the density, their blood becomes almost transparent. Of course, that would mean reduced oxygen transport to their cells, which is why they only do so when sleeping, when they are mostly inactive. That is their most vulnerable moment after all, hence they need extra protection when doing so. Keep in mind that this only happens if they sleep by their own will. If you anesthetize them, red blood cells will still be circulated, hence not transparent. When they wake up or when they are disturbed, red blood cells will be released from their liver and quickly circulate through their bloodstream. Hence, they could resume activity with relative ease. So yeah, they are highly adapted for this. During breeding season, males would fight each other to establish their breeding ground, or you could say breeding leaf. Glass frogs of the Cantrolenidae subfamily will hang from the leaf by their feet and grapple each other, utilizing their humeral spines to defeat the other male. Meanwhile, glass frogs of the Hyalinobatrachinae will just wrestle on leaves, which is a little bit boring in comparison, but still quite something. After they establish their breeding leaf, which is almost always above the stream by the way, they will call for females. Each species produces different calls, but they typically emit chirping calls during breeding season. Attracted female will approach, then they will mate by amplexus. Fertilization occurs externally by the way, as is the case in most other frogs. Soon after, females will lay eggs. Different species lays different formation of eggs by the way. Actually, some even lay eggs on rocks instead of leaves. But anyway, After the female lay eggs, it will usually leave. Reproduction costs a lot of energy after all, and they need to replenish said energy. Meanwhile, the male will stay on its leaf, guarding the eggs. Sometimes, it will call and mate with other female on the same leaf. On average, eggs will hatch before 2 weeks. Either the leaf falls into the stream, or the larvae themselves will fall into the stream. Same result basically. As larvae, they feed on detritus until they metamorphose into froglets. As with many other arboreal animals on the tropics, they are vulnerable to deforestation. Some of them have been categorized as critically endangered because of it. Because of their unique ability, especially because they could temporarily store their red blood cells in their liver, and vice versa, researchers are interested on them. Though, I personally would be delighted if their taxonomic uncertainties would be resolved soon enough. But hey, at least they are getting attention. Hopefully things would be better for them. But for now, let's just learn what is known. And that's all for now. Oh, by the way, while they are the only transparent land vertebrates that we currently know, some are at least translucent. Maybe I'll make a video about them soon enough. Anyway, enjoy your day.